Hey guys, I want to show you a quick little program that I wrote. Lily, why don't you tell the kids what happens?
What happens when you press the button here?
And that's called a bump switch. What happens there?
These wheels move.
And they move for, do you know how many seconds?
They move for 5 seconds.
Okay, go ahead and show them. So she's going to hit it. They turn for 5 seconds.
2, 3, 4, 5.
And then they turn off. And I'm going to walk you guys through the quick program that I wrote to make them do that. So the first thing we do is we write a program. Now let's explain this task main for a moment that I'm going to highlight. So this task main right here, it says that there's a program about to begin. I want you to look at this brace. It connects to the very bottom brace. Braces are very important. This brace starts the program. It has to have one to end it. So something you can always do, if you're not sure what brace is for what, you can do //. It turns green, which means it's a comment. And you could even write like start program brace. I do this with kids when their programs aren't functioning well. And you could even call this one like stop program brace. That way they know everything inside of here is the program. Now let me explain this while 1 equals 1 thing here. So programs just run through. They do line by line by line by line until they get to the end, and then they stop. So if you want a program to continually work forever, you have to tell it while 1 equals 1. Now, why don't we just do while 1 equals 1? Because sometimes it's like you could do less than, sometimes you can do greater than. So if you just want 1 to equal 1, you do equal. So why do we do 1 equals 1? Well, because 1 equals 1 indefinitely, which means this program will go forever. If I said something like while 1 equals 0, this program would go through and say, hey, I have a program. Hey, my program is starting. Hey, 1 does not equal 0. So it would skip all of this, and then it would just stop the program. But if you have right here, while 1 equals 1, your program goes through and it says, okay, so as long as 1 equals 1, I'm going to go in between this brace. Notice how this starts the while loop. Okay. We call that a while loop. And how this one ends the while loop. Okay, so since 1 equals 1 all the time, my program will continually just go through here, go through here, go through here. The next thing, this is called an until command. See how it says until bump? And remember, this is the name we typed in whenever we did our, I'm recording, so you know. This is the name of our bump switch that we called bump switch. So you notice how I had to use a capital B and a capital S. So they're saying, hey, until you hit the bump switch, just stay. So it's going to stay right here. See where my cursor is? It is going to wait until somebody hits that bump switch. Once somebody touches the bump switch, it's going to start the right motor at 63, and then it's going to start the left motor at 63. It is going to count for 5 seconds, and then it's going to stop the motors. And then it's going to come to this brace, and it's going to stop my while. But since 1 still equals 1, it's going to go back, and it's just going to do this indefinitely. Notice how after every command, you need a semicolon. And I want you to get used to the blue means it's natural language, and the red means that is pulling from something that we called. So like this one is over here. If you look at like robot movement, see how it says start motor? That came from right there. So start motor is a program. Right motor is what I want it to start. 63 is the speed. So I'm going to download this to the robot so you can see what happens when you hit download and compile. Okay, it's checking for connectivity to the robot. I do have my orange plug, and now it is not going to start the program until it registers everything. There it goes. And remember, you guys can see down here. Here's a live feed of everything. Remember how we talked about the light sensor? So like now the light sensor's at like 187. I'm going to cover up the light sensor. Notice how it increases in value. Okay, so all of these items on here on this test board, on this test robot thing, they're in real life time. But I'm going to hit start, and what start does is it goes to task main, and then it goes to while equals 1, And that was how it's green. It's stuck on start right motor. It really wants to start this motor over here, but it won't start this motor until the thing above it is accomplished. So the thing above it says until bump switch. So I'm going to do, I'm going to push my bump switch. And now notice it's waiting for 5 seconds. It's not going to stop the motor until it gets to the wait is done. So it has to do everything step by step by step. So again, one still equals 1. So it's going to go and it's waiting for me to hit the bump switch. Once I hit the bump switch, it's going to start my motors. It's going to count for 5 seconds. After it counts for 5 seconds, it's going to stop my motors and loop back up to my 1 equals 1. So I'm going to hit this again. You can see both are spinning. And something neat you can do is I'm going to reprogram this. I'm just going to put a negative in front of the 63, and you should see the right motor is going to spin in an opposite direction. And let's make it as fast as, let's make it like 100. Instead of just 63, let's make it 100. So it's going to spin 100 in the other direction. And let's make our left motor go really slow at 20. If you make it go too slow, if there's any resistance, it's not even going to go. It's not going to have enough to jumpstart it. So every time you change it, you have to compile it and download it again.
You
And-
start communicating like right around 1:30. We ordered a house.
That's my dad. Dad, say hi.
It's gonna be
No.
I'm recording. I'll be done with this video soon. Okay, when I hit it, it's going to go to task main. It's going to wait until I hit the bump switch. And the difference this time is I want you guys to see this one should spin faster and in the opposite direction, as long as I have my left and rights correct. And this one should go slower. So it is waiting for the bump switch. This is the bump switch. And, oh, I had them backwards. So this one's the right one. It's backwards to me. So the right one went opposite. The left one went really slow, and it waited for 5 seconds. And this until bump, you don't have to use until bump. You could even say something like until sensor value bump switch equals 1. Because remember, when you hit it, it turns to a 1. But there's just a quick video showing you how to program, how to start motors, how to count for 5 seconds, and how to stop motors. We'll get a little more intense as we move up.